Awesome. Hello, everyone. Today I'm going to be talking about using funcX as kind of the back end to a federated learning library system, whatever you want to call it. So I'm all about making things easy. Certain people in this room will tell you that I like doing things the easy way. I think it's a smart way of doing things, but computer science is difficult. This is why we all have jobs. Machine learning is even more difficult, unless you're a first-year computer science undergrad, in which case it will solve all the world's problems. Even more so than machine learning, federated learning is probably actually very difficult. If you look at any of the current libraries out there, federated learning might actually be one of the most difficult things in computer science. But it doesn't need to be. So what is federated learning? It's the idea that you have multiple siloed, presumably data sources, or just data sources in general across many different machines, different locations, different formats, collecting data, storing data somewhere. And you want to perform some sort of machine learning task on this data where it is presumably infeasible to move the data from these edge locations to some large central HPC system to perform a training task on it. We good? Oh, that's dangerous. Awesome. So these different data sources, you have some sort of machine learning model that's trained individually, and then there's a aggregation mechanism generally in a centralized location. There are security aspects of this that some people like. This is why this is quite a popular method in healthcare, where you can train on data without moving the data, and then you're essentially just moving model weights around, which you can extract certain principles of data and summary statistics, but in general, it's a lot better than just moving health records from system to system. This is also what Google and Apple use in order to do the specific text prediction that you get on your phone. Obviously use the end user, even though you'd expect Google and Apple to do this, to move your local texting data off your phone. They try not to when they don't need to, and instead they can just move those predictive models themselves up to the cloud and aggregate all those together, send the final model back to your phone, and the cycle continues. There are many challenges with this. One of these is that a lot of the federated learning models require a very static, very well-defined network between all the different endpoints, or complete control over your device in the cases of Google and Apple. The DIY methods, the current systems that are out there for folks like you and I, require a lot of manual configuration. They don't do well with heterogeneous hardware, which is becoming increasingly common. And some systems that will go unnamed don't really provide complete solutions. They just give you little bits and pieces and say how they would like you to do it, and then leave you to do the rest. So our solution, we call it funcX, federated learning on funcX, very creative. Not to be confused with Flux, which I saw come up 2 talks ago. So basically, the idea is we wrap all of these relevant functions that we would want to deploy to edge devices using funcX, so that way we can deploy them to any device that we like. What this allows us to do is we launch all these different training tests to the endpoints, whatever the user specifies, and we can use any relevant data that is accessible on that device. This is manually configurable to use the end user if you want to swap out functions. Like a really popular one we imagine would be the aggregation function, since that's kind of the most performance indicating aspect of this in terms of model accuracy. But it allows you to do whatever you want when you just have these nice little modules that you can move around. And our whole idea with this is that you define your machine learning model, you point it at the data on a given endpoint, and flocks. So what sets us apart? The most important thing, at least to us, is that you can perform federated learning really with one line of code for a very simplified, albeit example. But if you're somebody who's new to the machine learning space, the distributed computing space, it's a one-line plug and play, and you can go from there. obviously, we're here, funcX Fest. This relies on serverless. And so this incorporates all the reasons that funcX is great into federated learning. Basically, the ability to run anywhere that Python can run, Flox can run. So now it's applicable for all of FL. This is somewhat of an end-to-end system. Granted, we don't have all the functionalities of some of the more prominent or quote unquote older, even though federated learning has only been around for a few years, systems like the Flowers or TensorFlow federated. But you know, this is a system that you can plug your data and model in and actually perform real federated learning and get it out without having to do any extensive manual tuning yourself. And we don't impose or require any sort of model constraints. Basically, if you have a model defined in TensorFlow, you know, you can plug it in and it'll go. So initial experiments, we found, obviously, with similar algorithms, the algorithms weren't impacted at all by using serverless versus a more defined static network in terms of performance, like model accuracy type performance. We do, because this is sort of like a distributed system, get faster convergence with respect to time against using a industry grade GPU with just our little test bed of 10 different endpoints running across Raspberry Pis, Jetsons. We had a Google Coral in there at one point, but it got finicky. And then just a couple of old PCs that were lying around the lab. Obviously, we've heard a lot of people talk about the great things that funcX can do, so we're hoping to scale up and out soon. And we see, at least in this case, that the aggregated model performs as well as the centralized model, given enough time, enough data, et cetera. Another aspect of this too is you know, we all know that with machine learning, the more data, the better. But even this shows that if we distribute that data across 10 different endpoints, so we're really only training individual models on 1/10 of the data, the aggregation method is performant enough that it can account for that and still get nearly the same performance over time. The system aspect of this, we measured the different communication times, data processing, training, overhead, and we found that the system itself has relatively low overhead, especially with regards to communication time. Now, that's something that obviously, as you optimize your model and optimize what data is being moved and isn't being moved, that communication time can go down. But the system itself is a very, very small overhead with respect to everything else. And we also believe that these results kind of motivate that compute where the data is at mentality. So using Flox, very difficult. Pip install Flox or PyFlox. Flox was already taken. It's a Python wrapping for some JavaScript database thing. We don't know. Then you can just import the federated learning function from Flox and then provide the necessary model that you want to use and your list of endpoints. That's probably the most difficult part, is remembering all your UUIDs from the many different machines you've set up funcX endpoints on. Define how many federated learning loops you want, how many epochs per loop, what data source. So we have provided that you can just plug in Keras as the option for data source, and you can use any of the TensorFlow or Keras sample data sets if you just then specify which one, or you can specify local data set and then just point it to whatever the file or sensor location is and use local data. And then the last step is wonder what you do with all the time that you save, not having to set up complex networks and, you know, compute dependencies, yada, yada, yada. So future work, we do want to add a lot more functionality. So make the individual components more exposed to the end users for those who are more experienced with federated learning. Right now, this acts as like a great first look, kind of like a intro to FL class sort of thing. But there's a lot of further functionality in federated learning that these different these different systems that are out there currently provide. And so we are kind of running that balance now of how complicated do we allow you to be versus how simple do we try to keep it. We also want to improve data integration. So if you have data in multiple locations, It's not just in the same type of named folder in each place, that there's some sort of data finding function that we allow you to use rather than just having to provide a list of where you hope your data is. Another thing that we've started working on, we actually have a poster that just went in on this, is auto-tuning federated learning. So we want to balance the workload for device capability. Obviously, if you're running a Raspberry Pi along with a GPU node somewhere, the Raspberry Pi might take a little bit longer. And so we would naturally want to give it less work. And so how do we balance those compute trade-offs while not losing performance accuracy-wise, but gaining performance time-wise? So we have some initial tests there, just trading off those epochs and the aggregation frequency. Another thing that we're interested in is cost-aware FL. So if we can move data, let's say it's not a very sensitive, my time's almost up. If it's not sensitive data and we can move it, should we? So if it's on a Raspberry Pi, it might make sense to move it because Raspberry Pis are slow. And so we're thinking about integrating this with our current system, Delta, which I think I talked about last year here, which is effectively our scheduler on top of funcX for moving funcX tasks where they should be. Finally, one interesting application is using FL for system performance. So being able to learn different performance embeddings across different systems, across different functions, and kind of have this meta FL loop across different locations. Yeah, so basically the main takeaway is Phlox makes FL easy, and we can only do that given we have funcX behind us. This is everybody who's kind of worked on it, our relevant publications and questions.
I have one.
Yeah.
So is the compute, like the training itself, actually happening on the edge devices?
Yeah.
Okay. So what you're spinning up a funcX endpoint on each edge device, offloading the work there. And what about if you wanted to, is it possible to just use it to export the data to some sort of, like if I have a big compute server somewhere?
That's coming in Phlox 2.0. Yeah.
Okay, thank you.